Okay, guys, so when you're solving a right triangle problem, you are having to try and identify what the given information is based on the sides of your triangle and relate that to one of your trig, one of your trig ratios. So you have sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So in this first triangle, if I were to put my relationship, so 23 is the given angle, so that means this is my opposite, this is my adjacent, this is my hypotenuse. So if I'm going to set up the problem, I'm going to use anything that has opposite and hypotenuse, which is sine. So we know that the sine of an angle is the opposite over the hypotenuse. Now I can just substitute the given information. So I know that the sine of 23 degrees is x over 40. And then to solve this problem, you're just going to go ahead and multiply. It's like solving a proportion. We're going to multiply both sides by 40, so they cancel out on this side. And then what you're going to enter on your calculator is 40 times sine 23. You actually don't have to hit the times on your calculator. It will understand. And you should get 15.63 for your answer. Okay? So in this next example, again, we have a 38-degree angle, and we're going to look at then the ratios of the sides. So this is our opposite, this is our adjacent, this is our hypotenuse. So I want to deal with something that has adjacent and hypotenuse, and that would go with your cosine. So we set it up, we write the cosine of the given angle is the adjacent over the hypotenuse. So now my unknown is in the denominator. So there's a long way to do this and a short way to do this. So I'll do the long way off to the side just to give you a justification for it. So what we're going to do is we're going to cross multiply. So when I cross multiply, I get x cosine 38 equals 12 times 1. And then we want to solve for x, so we're going to divide both sides by cosine 38. And what you should notice is then we have our x isolated. So when you have your unknown in the denominator, the short way is just to notice that these two are going to switch positions. So you will end up with x equals 12 divided by cosine 38. So when your unknown is in the denominator, it turns into a division problem. And you should then get 15.23. Okay, so that's how you set up your problems when you have an unknown side. Now, the only other thing when you're doing applications, there is one other term or two terms that are related to be able to distinguish. You'll hear things called the angle of elevation and the angle of depression. And basically, they're both with respect to the horizon. So I have this triangle here. Imagine that this is a building. Okay, so right here is a building. I'm standing up on top of that building. As I look straight out, that's considered the horizon. I am looking out on the horizon. So if I want to look down at my dog sitting down on the ground, that is the angle that my eyes are going to go through. Since my angle is going down, that is called the angle of depression. Notice that it is outside of the triangle. It's actually not part of the triangle. On the other hand, my dog is down here and he's looking up at me, so his eyes are going through this angle. That's called the angle of elevation. Sometimes they'll say the angle of elevation with respect to the ground. Okay, so notice though, we have basically alternate interior angles, and the angle of elevation and the angle of depression are the same measure of an angle. So sometimes when they give you the angle of depression, you can then just label your angle of elevation equivalently. Okay, and again, that's because of your alternate interior angles. So let's go to the next page and we're going to try and do a couple problems so to set them up. So we have a kite is flying at a 40-degree angle of elevation to the ground. All 80 meters of the string are let out. Find the height of the kite. So you know we're dealing with right triangle problems. So sometimes you can just go ahead and draw yourself a right triangle, and then we'll label things as we go. So my kite is going to be out here. So here's my kite flying up in the air. The 80 meters of string are right here. So we'll label this the 80 meters of string. And the height of the kite is going to be represented along a perpendicular. And so we want to find out what is that height. The angle of elevation, that's the 40 degrees, that is going to be down here. So once again, on the inside of my triangle, I can put my relationship. That's opposite. This is adjacent. That's hypotenuse. So opposite and hypotenuse go with your sine, your SOA, so katoa. So we're going to go the sine of 40 degrees is the height over the 80 meters. And again, to solve for your height, you're going to multiply both sides by 80. That isolates your h. So on your calculator, you can go 80 sine 40, and that should give you approximately, if you're doing it to the nearest meter, we can say 51 meters. Okay? Now this next problem, you are standing atop the 150-foot Nordstrom building looking down at your car at a 50-degree angle of depression. How far from, whoops, you aren't seeing it. It says, how far from Nordstrom's did you park? How far from Nordstrom's did you park? Okay, so let's see what a diagram like that would look like. So here's Nordstrom's, here's the building, and you are standing on top of the building, and you're looking down at your car, which I guess most of you are too young to drive, so your parents' car right now. All right, this is Cole's new Dart. I think that's what he just bought. And we want to know how far from Nordstrom's did you park. So this is going to be our unknown. Now it said the angle of depression, so that's going to be this angle. You're looking down here at a 50 degrees. So what we can do is we can mark this angle down here as 50 degrees. We are assuming Nordstrom is 150 feet high, and we're trying to solve for x. So if we label the insides, based on this 50 here, this is going to be the adjacent, this is the opposite, this is my hypotenuse. So opposite and adjacent, the hypotenuse has nothing to do with the problem, so that's going to be a tangent. So we have that the tangent of an angle, which is 50 degrees, is the opposite, 150, over the adjacent. That's what we're looking for. Since my unknown is in the denominator, this is going to become a division problem. So x equals 150 divided by tangent of 50. And when you work that out, it means you parked about 125.86 feet away. Okay, so I hope that helps and that then you can do your applications from there. See you on Tuesday.